You are welcome back to the Twitter Think channel. In today's video, we have an exercise on the board and we are going to take our time to break this down to the simplest form, and I will explain for you to understand. So we will go through this exercise together. Now, you need to look at introduction to conditional probabilities. I've separated the introductions accordingly. You need to look at each of them because I'll be applying complement of set and non-complement set here. So you look at these videos. If this is your first videos, you see them in the playlist conditional probability. In today's exercise, we have a question which says that an electrical engineer at GRIDCO is given two separate toolboxes to keep his working tools. The first toolbox has 4 white fuses and 3 black fuses, and the second toolbox has 3 white fuses and 5 black fuses. And then the question says, suppose the engineer selects a fuse from the first toolbox and place unseen in the second toolbox. So he took a fuse from the first toolbox, place it in the second toolbox without having a look at it. Now, what is the probability that A, the fuse drawn from the second toolbox is black? And B, what is the probability that the tool drawn from the second toolbox is white? And C, both fuses are of the same color and one is white. So we will take a look at this question when we get here. Now, this is a little complex, so I'll take my time to break it down for you to understand. I believe that by the end of the day, I will be able to help you to understand this. So the first thing we need to do is to write down our data. So the first thing we will do is that we will let W to equal to what? White fuses. Let B represent the black fuses. So now let's use 1 and 2 to represent the first toolbox and the second toolbox, okay, respectively. So we have W1 to be equal to white fuse selected from the first toolbox. Then let B1 be black fuse selected from the first toolbox. Okay, so I have made my own toolboxes, okay, and then I use pencil colors as my fuses. So I'll use it to explain so that we get the concept very well. So let's box on. Let's see what we have. Okay, so these are my toolboxes, okay, my first toolbox and my second toolbox. I did not get a white color pencil to represent the white fuses. So let's assume that this we have here is our white what? Fuse. So the question said that the first toolbox has 4 white fuses and 3 black fuses. So let's drop 4 white and 3 black here. So this is 1, this is 2, 3, and this is 4 white fuses. So I'm dropping it here. Then it said 3 black fuses. So these are my 3 black what? Fuses. So I'm dropping it in. Then the second one, we have 5 black fuses and 3 white fuses in the second what? Toolbox, making it what? 8. So I have 2 here, 3, 4, 5. So let's drop it here. Then we have 3 white fuses, which is this. All right, are we all okay? Now, let's find the probability of the first toolbox. Before we can find the probability of the first toolbox, we need to find the total number of what? Fuses we dropped here. It was 4 white fuse boxes I dropped here, plus 3 black, making what? 7. So total number of fuses are 4 plus 3, where 3 are the black fuses, giving us what? 7. Okay, so this is the sample space. Why are we supposed to find the probability of the first toolbox? This is because before we can tackle this question for this side, we need the probability of what? The event that happened in the first toolbox. In conditional probability, because we are going to condition on event 1, we need to find its probability and write it down. So the probability of the first toolbox is giving us probability of white fuses in the first toolbox, okay. How many white fuses do we have here? 4 of them divided by the total, which is 7. So this is 4 over 7. Then we find the probability of what? Black fuse. So probability of black fuse B in the first toolbox is giving us what? 3 dividing 7. Now let's move on to the probability of the second toolbox. But before we go there, look at the question. He said, suppose the engineer select a fuse from the first toolbox and place unseen in the second toolbox. He picked an unseen fuse. So let me pick one unseen, okay? And drop it here. Good. What is the total number of fuses in the second toolbox? So we have, the first time we had 5 black fuses here. So 5 plus 3 white from the beginning. Now we added 1 plus 1, giving us what? 9. Are you okay? Now we are moving on to the probability of the second toolbox. Now listen very carefully. Because I picked a fuse and drop it here, and we are all assuming I did not see the fuse, whether it was black or white, I don't know. Assume that you also don't know. Okay. Now, because we don't know the type of fuse we drop in this box, we need to find the probability of this box in 2 ways. We are going to have 2 scenarios. The first scenario is I picked a white fuse and dropped it here. To comprehend, the second scenario is I picked a black fuse and dropped it here. So what is the probability of this box? Assuming it was a white fuse I dropped here, and when we finish, we will then come and find what is the probability of this box, assuming it was a black fuse I picked and dropped what? Here. Do you understand what I say? Okay, so let's solve for the first one. Let's assume we picked a white fuse and dropped it here. Okay. The total number of fuses we now have here is 9. If a white fuse was added, in the beginning, how many white fuse was here before we added the 1? It was 3 white fuse. Okay. So in that case, if we picked a white fuse as we are claiming here, then when we add that white to the 3, we get what? 4. So probability of, now watch, white fuse. Let's find the probability of white fuse first. Good. Assuming or given that a white fuse was added from the first box, so I'll label here 1 because W1 represents fuses from the first box. So now this is a conditional probability of a white fuse given that a white fuse was what? Added. Good. If that is the case, what are we going to get? We are having 4 because it was originally 3 divided by what? 9. We are not done. We need to find the probability of the black fuse here too. So conditional probability of black fuse, given that we are all assuming it was a white fuse. A white fuse from the first box was added. Now, because it is a white fuse, we can't add it to the number of blacks. So we still have 5 blacks here dividing 9. Do you understand now? Good. The next thing we will do is to move on to the next scenario, assuming that the fuse we added was rather black, not white. Now let's get the conditional probability. P of first we will find for white fuse. Of white fuses, assuming that a black fuse was added from the first box, what are we going to get? If we need the probability of white fuse, how many white fuse was there originally? It was 3. Dividing the total is 9. We can't add the black fuse here to white. That's why we had 3 over 9. Then the probability of black fuse, assuming a black fuse from the first box was added. If that is the case, we already had 5 blacks there and we added another black, giving us what? 6 over 9. Now if we break this down, we have 1 over 3, and this one is giving us 2 over 3. The first question says, assuming the fuse drawn from the second box is black. So we are finding the probability that the he has now picked a fuse from here and the color is what? Black. So we have to use these two scenarios to solve. So we are finding probability of black fuse picked by the engineer. In that case, let's move on to the first scenario. The first scenario was a white fuse was added, but we are looking for the probability of black. To be able to find that, we will take the probability of white fuse, because we are dealing with white fuse was added. What is it? Is here in the first toolbox. Remember that the fuse added was coming from the first toolbox, so I'll pick this one. So this is giving me W1. Multiply this by what fuse was picked. He picked black. So we are going to look for black in the first scenario. Yes, black. Here is it. Assuming a white fuse was added, which is here. So we will multiply by P into black as white fuse was what? Added. Do you understand? That is the first scenario. Union, which means plus. Now let's move on to the second scenario. Now we are now assuming that we are looking for the probability that he picked a black fuse from here and a black fuse was added from the first toolbox. That's what we are looking. So we are coming to use this scenario. So now I'll add it to probability of a black fuse was added. Where is it? Here. That black fuse was coming from box 1. So we have to use B1. So I'll use what? B1. Multiply it by the conditional probability. Now let's move here. What are we looking for? We are assuming he picked a black fuse. So we are now going to focus on wherever we see black fuse first. This is not the one. It is this. A black fuse. So we are finding the probability of a black fuse, assuming he dropped a black fuse from the first box. So this one. We have P into bracket B as B1 was added. So now this is the total probability formula that will help us to find the probability of what? He drawing a black fuse. So now let's solve. So what do we have here? We have, what's the probability of white fuse? We had what? 4 out of 7 times, what's the probability of what? Black fuse when a white fuse was added? Where is it? Here. We had 5 over 9. Okay. Then plus, what is the probability of black fuse? That is 3 over 7 times, what's the probability of the black fuse? Assuming a black fuse was added, we come here. That is giving us 2 over 3. Now when we multiply these two, we are having 20 divided by 63. This time this. Plus, this can cancel this. So this times 1, this times 1. This is giving us 2 over what? 7. When you punch these two on the calculator, the answer we are getting is 38 over 63. That is approximately 0.603. So the next question said, the fuse drawn from the second toolbox is white. I think here I wrote 2 in the beginning, so I corrected it. Okay, it's supposed to be fuse. Now we are looking for the probability that he picked a white fuse. Okay, so P of white. Now we are going to use the two scenarios again. The first scenario is a white fuse was what? Added, and he picked a white fuse. Okay, so now let's talk about a white fuse was added. If a white fuse was added, then we have the probability of what? W1, white fuse. So now we multiply by its conditional probability, P of he picked a white fuse. That's what we are looking for, so it will come first. What condition are we talking about? A white fuse was added, so we will look for the one with what? A white, so this one. So we have W1. Do you get it? Plus, then the second scenario, a black fuse was added, but we are looking for the probability of what? White that he picked. So we will use this formula. So now we have P of a black fuse added, B1 times P of, we are looking for white. So we write our white. A black fuse was added is here. B1 and white. I've already written the white, so I'll put my B1 here, and that's the formula. So this you are seeing here is the total probability formula, which means the first scenario, which means we are looking for the probability of a white fuse he picked, given that a white fuse was what? Added from the first box. Here, we are looking for the probability of a white fuse he picked, given that a black fuse was added from here. Okay, so this becomes, what is probability of P1? 4/7 times, he picked a white fuse, given that a white fuse was added, is here. We have 4/9 plus probability of B1 is giving us 3/7 times probability of he picking a white fuse, given that a black fuse was added, is where? Is here. We have 1 out of 3. 1 out of 3. When we add this to 16/63, so you can multiply this and get 16/63, plus this 3 will cancel this one. This will give us 1/7. Now adding this result together is going to give us 25/63. This into decimal is 0.3968. This is in 4 decimal place. From here, let's move on to the next question. I hope you understood this one. He said both fuses are of same color. So let's find out. Let's use the first and second scenarios again. Now he picked same color. Let's analyze this. It means that when he picked from the first toolbox and drop it here, if the color was white and he was picking from the second toolbox, he picked the same color. If the color was black, he picked the same black color. That is what this question means. So assuming I drop white here, I picked white. Assuming I drop black here, I picked black. Okay, so now probability of same color will give us P. Let's assume that a white fuse was added, so it means he picked a white fuse. So probability of white fuse, W1, times probability of he picking a white fuse. Okay, given that a white fuse was added. Do you understand now? So the same color, every color is the same. Plus the second scenario, we are going to black. So that is giving us the probability P of black fuse that he added times probability of he picking a black fuse, given that a black fuse was what? Added from the box 1. So you could see the second condition is for black, the first condition is for white. Okay, so when we input the answers, we have this is giving us 4/7 times, we have what? White giving us 4/9 plus, then we have black, which is 3/7 times, we have black, where is it? Okay, 2/3. So this time this, we are having 16/63 plus, when you cancel this, we have 2/7. So when you punch everything here on the calculator, you have 34/63. So this is going to give us 0.597. Let's move on to the D. The D says we should find the probability of 1 is white. I cleaned that question. Okay, now when we come here, I don't know if there is an error with this question. So I couldn't really analyze the question. If any of you is able to do this, please drop it in the comment box for me so that I can make inquiries too. Okay, so from all that I tried to do to solve this, I couldn't, so I have to do research about this question, and we find out that if the question is saying 1 is white or 1 is black, either 1 is white or 1 is black, then we can solve this. So we are going to use that scenario, either 1 is white or 1 is black, to solve it. Okay, but you can find out from your lecturer, or who, if you come across this similar question, and find out how to go about this, or if the question was incorrect. Okay, so if we are using the idea that either one is white or one is black, then we are going to go into what? Complement. And complement of what? Complement of the same color. If one is white or one is black, then if we take the total probability, which is 1, and we subtract the same color from it, it should give us the same answer. Okay, so probability of this, which is 1 is white, P of 1 is white. You can solve this as 1 minus probability of what? Same color. Then if we use the same idea, then we are going to have 1 minus 34 over what? 63, which is going to give us what? 29 over what? 63. And that will be our answer. That is if we are assuming that the question is asking us that one is white, either one is white or one is black. Okay, there is another way that we can solve this by using the two scenarios. Okay, it's very long. Since we spent so much time with this one, I think you can do it that way. I'll ask you to use another way. Use the two scenarios to solve for one is white, one is what? Black, and get me the same answer, 29 over 63. You can solve this and drop it in the comment box under the solution. That will be your assignment for this question. And I have dropped a lot of exercises under conditional probability. Please look at these exercises and share these videos if these videos has been helpful to you. The only thing that you can use to support me is to subscribe to my page and like and comment, especially the comment. If you have any questions, drop it there. If you want to share an idea, please drop it there. If there are other easy ways that we can go through this and you know it and you can help, please help. Sometimes I don't know everything. Sometimes I have to learn. And sometimes I have to learn to understand what I'm teaching. Sometimes I even struggle. It takes me some time to understand some of these things. Okay, for your sake, I have to prepare well and come and teach you. So please support this page. My name is Daniel, and I'll see you in the next one.